Right. Number 5 in this unit, we're going to skip clear up to number 5. And they've given us right here that BC is parallel to EF. So these two lines right here are parallel. Again, please note that they're not congruent. We don't know that they're congruent. We just know that they're parallel. So we're going to go ahead and write BC is parallel to EF right here. And I changed colors. I don't know how I do that. That was a given. All right. Now, couple of things. First of all, remember if you've got parallel lines, that really means that your alternate interior angles are congruent, your alternate exterior angles are congruent, and your corresponding angles are congruent. So it's really telling us about angles when you have parallel lines. So when you look at these two lines as being parallel, I wonder if I don't want to draw through my letters right there, but those two lines are my parallel lines. Let's look at this as our transversal right there. There's my transversal. So that's saying that I've got these lovely alternate interior angles that are congruent. Okay, now there's a few ways you can prove this one because this could be used as a transversal too, and you could say that these two angles are congruent. But you got another theorem that you could say vertical angles are congruent. You know that these angles right here are vertical angles, so they're congruent. So basically, you only need two angles. Remember when we are proving things, we've got our side, angle, side, angle, side, angle, angle, side, and our hypotenuse leg theorem. So we could prove it any of those methods. So let's go ahead. Let's choose two angles. Let's see how I can do this. We're going to get rid of this line right there. Okay, so we're going to go ahead. Let's choose E and C. Everyone okay that angle E? Whoops, I messed that one up. Let's go back to my pen. So angle E is congruent to angle C. And I can just call them E and C because there's only one angle right there. And those again were alternate interior angles. Since I've got the parallel lines right here, I know alternate interior angles are congruent. All right, and then let's do our vertical angles because we haven't done vertical angles before. At least I haven't in my examples. So I'm going to call that angle EDF. And I'm going to say that that is congruent. EDF is going to be congruent to BDC. Angle BDC. And that's because of our vertical angle theorem. The vertical angles theorem. All right, so far I've got the two angles. Now I've got to get a side. So let's go back to our nice, lovely givens because they told me something else. They told me that D is the midpoint of segment BF. Okay, so this D is the midpoint of this segment BF. So remember, that really tells me that those two sides are congruent. Sorry, this was a given. And then we're going to go ahead and say, well, that means that it cuts it in half. So the time or the between B and D is going to be congruent to the distance between D and F. D and F right here, that's just what a midpoint does. So that's the definition of a midpoint. All right. And then we're going to go ahead and say these triangles are congruent. I've got a side and I've got two angles. So I can say triangle. Again, watch out how you name them. Let's go ahead and call this one BCD. We're going to say BCD is congruent to triangle. Okay, now this one's kind of nice because I've marked which angles are congruent. I know that angle B is congruent to angle F. So F is going to go in the first place. Then C, right here, C is congruent to E. And then that leaves D as my last one. So those two triangles are congruent. Now, why are these triangles are congruent? We actually, in our proof, used E. We used these angles. Let's go ahead and write this all in blue. We used EDF. We used the vertical angles. Oops, sorry. Oh, dear. We used that angle. And then we used our sides over here. So notice that that side is not in between my two angles. Okay, so it's not in between it. So we're going to be using this angle, angle, side. So it's the angle, angle, side. Now, again, there's lots of correct ways to do this proof. So if you used F and B, oh, it's still going to be angle, angle, side. But if you used F and the vertical angles, then you got an angle, side, angle. So yours might be different than mine, but it could still be completely correct. So don't cross it out. Send it to me and I can check it. All right, so we know those triangles are congruent. That means all of the corresponding parts are congruent. So when you look right here, oh, let's not use yellow. So when you look right here, they wanted us to prove that ED, the segment between ED, is congruent to the segment between C and D. So this line right there is congruent to that line. And when you look at that, just kind of make sure that it's between our one angle and our three angles, one angle and three angles. Yes, indeed, those are congruent. Using our corresponding parts of congruent triangles are congruent. CP, CTC. That is a reason.